A cannon installed at the top of a hill can fire shells in all directions. So there is a cannon here and it can fire shells in all directions. There is an enemy bunker at the elevation angle of elevation phi. Angle of elevation means angle from horizontal. So here it is a bunker at this position. There is a bunker and the position of bunker is making an angle phi with the horizontal. So that is called angle of elevation and a distance d from the cannon. So this distance is given as d. All the shells fired explode in air in time t before they reach the bunker. So all shells they explode somewhere in the air itself and they cannot reach the bunker. At what angle to the horizontal should a shell be fired with a speed u to explode closest to the bunker? Now we have to find the angle theta horizontal from horizontal so that the explosion occurs closest to this bunker. So that is the question. So we have to find that angle. So the situation is like this. Suppose at angle theta, its path will be like this. And suppose it explodes here and the bunker is here. And we have to find the theta such that this separation, this is the separation between the explosion point and the position of bunker, let this be s. So we need this s to be minimum. Okay. And it's given that explosion occurs after a time t. Okay, so how to solve this? We'll find this position of shell because time is given and this theta is assumed. So the x coordinate will be initial velocity in x direction, that is u cos theta. This theta is actually made from horizontal, sorry. So u cos theta, so this is initial velocity in x direction, t, and plus half a t square, which becomes 0 because there is no acceleration in horizontal direction. All acceleration, which is gravity, is in vertical direction. So there is no acceleration in x direction. So x is equal to ut plus half a t square. So that half a t square terms goes to 0. Okay, and the y coordinate will be u sine theta t. This is ut plus half a t square, and a becomes minus g in y direction, t square. So these are the coordinates of this point, x comma y. And the coordinates of bunker are d cos phi and d sin phi. Now the separation between these two coordinates from the distance formula, distance between two coordinates formula, is under root. Or rather than putting under root, I am just squaring s. So it is x coordinate minus d cos phi square plus y coordinate minus d sin phi square. So, and x and y are these values. So we have to put x and y here, and then we have to see that for what value of theta this s square is a minimum. When s square is a minimum, s automatically will be a minimum. So we have to see for what theta s square is minimum. So for that, we'll put d by d theta of s square equal to 0. So this will give the theta for which s square is a minimum. Okay, so rest is all maths. We have to put the values of x and y, differentiate with respect to theta, put equal to 0, and solve for theta. So that is to be done. And I'm solving. You can just verify that it is done correctly. See, s square is equal to, just put the value of x, u cos theta t. That's the value of x. Similarly, just put the value of y, u sin theta t minus half gt square minus d sin phi whole square. So this is s square. So d by d theta of s square. So differentiate this with respect to theta. So by chain rule, 2 times u cos theta t minus d cos phi. Phi is a constant, only theta is a variable because this phi is given. Theta is variable because cannon can fire at any angle, so theta can change, so it's a variable. So differentiating, while differentiating, so using chain rule, first we have differentiated this, then into differentiation of this term. So this will become ut as a constant, and differentiation of cos theta is minus sine theta. Okay, so this is the differentiation of first term. Second term, again 2 times the whole expression u sine theta t minus half gt square minus d sine phi. Then we have to multiply by the differentiation of this term using chain rule. Ut sine theta will be cos theta, and rest of the differentiation will be 0 because there is no theta term, and put equal to 0 then. Now we have to solve further. So this implies 2 will be cancelled. This implies u cos theta t minus d cos phi. Even this ut will be cancelled into sine theta is equal to u sine theta t minus half gt square minus d sine phi into cos theta. Okay, I'm bringing that cos theta term here, so it becomes tan theta. So we have to solve for theta, and this is u cos theta t minus, we're expanding this bracket, t into tan theta, or you can write sine theta, okay, tan theta minus d cos phi into tan theta. Uh, there is a theta term on this side, bring it on the other side, so it will come with minus u sine theta t, and it will be equal to minus half gt square minus d sine phi. Okay, so solve for theta from here. So cos theta into tan theta, it will become sine theta. So this term is u sine theta t, which will get cancelled by this term. So simply we are left with d cos phi tan theta equal to half gt square plus d sine phi, and from here we can find tan theta. So it is simply half gt square plus d sine phi divided by d cos phi. And if you find theta, then this will be tan inverse of this expression, tan inverse of this expression. So I'm just copying and pasting it here. So this is the expression for theta. Okay.